So today we're going to go over patterns and linear functions. So there are a decent amount of definitions that I need you to write down. So the first is an independent variable. Some people like to call this the input. So you hear of input and output. The input is always the independent variable. And this is the variable that doesn't depend on another one. So it might be time. It doesn't depend on anything else. And then you have the dependent variable, which is the output that changes in response to the independent variable. So it changes because of what the independent variable is doing. So a function is a relationship that pairs every single input with one output. Okay? A linear function is a function whose graph is a line that is not vertical, meaning that it's not an up and down line, but it is a line and it's horizontal, it's diagonal, but it's just not straight up and down. And then the value of a variable could be determined by the value of another variable. And this relationship can be represented using four things: tables, words, an equation, and a graph. So we are going to have problems where we're going to do all four of those representations for one specific problem. Okay? So the first problem that we're going to do, again, we're doing all four specific parts for it. So it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure that they form? Represent this relationship using a table, words, an equation, and a graph. So first things first, let's fill in this graph, okay? This table. So as you can see, if we look at the number of rectangles, we're going to have one rectangle, right? We have one rectangle right here. I don't know why it's making points everywhere. So we have one rectangle right here. Now we know that rectangles have the same length and the same widths. So if we add up all the perimeters, we get 6 plus 1 plus 1, which is going to be 12, 13, 14. Our perimeter ends up being 14, meaning that our ordered pair, if we go to plot this, is 1, 14. Okay? So now, if we look at the next picture, it's two rectangles. So here we know we have another 6 here, and we have a 1 here and a 1 here. So we'll have 12, 13, 14, 15, 16. So it only changed by 2. And this point would be 2, 16. Our third, we have 3 rectangles. We have an extra 1 here and an extra 1 down here. So again, it's only going up by 2. And I get 18. So I get 3, 18. And then lastly, without even counting, we know that this is going to be 20. So we get 4, 20. So our table is filled. So that's good. So now we want to describe this with words. Okay? So if we take a look at this, we already discovered that it's only increasing by 2, right? So the way that we want to describe this using words is that we are increasing perimeter by 2 each time a new rectangle is added. Okay, so we did words now, and now we want to look at equation. So this is going to be the hard part, okay? I'm going to change colors for this. Whatever the value that it's going up by is going to be the value that you're going to multiply your x by. So as we can see, this is going up by 2 every single time, right? We go from 14 to 16, from 16 to 18, and from 18 to 20. So what we're going to do is we make our equation y equals, y is our perimeter, so our perimeter equals 2 times x. So this always happens. Whatever this constant is that it's increasing or decreasing by, we multiply it by x. And then we want to add what we would start with if we had 0 rectangles. So if we follow this pattern backwards, we would have 0 rectangles with a perimeter of 12. and we add that, and this becomes your equation. So it's always the constant that's it's increasing or decreasing by multiplied by our x plus whatever our perimeter would be if you had 0 rectangles. Okay, we are going to do more. It takes a lot of practice. So if we were to just quickly graph this really quickly, this would be number of rectangles, and the perimeter would be over here. I'm going to delete that. That was ugly. Okay, so we know we get 1, 2, 3, 4 rectangles. And I'm just going to estimate here. So let's just say that this is 5, 10, 15, and 20, okay? So with one rectangle, we were at 14, which is going to be right over here. 2 rectangles, we were at 16. 3 rectangles, 18, and 4 rectangles, 20. Okay, so this would be, I'm sorry guys, my dog is eating a bone. Stop it. So this would be just a quick sketch of this representation. Okay, great job guys. So I want you guys to try this one on your own. Do the same thing that I did. Okay, so you're going to make a table, describe what's going on with words, write an equation, and then graph it. So the next problem that we have is this one. It says the table shows the relationship between the number of photos, which is X, that you take, and the amount of memory, Y, in megabytes left on your camera. Is the relationship a linear function? So all that asks is it a line? Is it constant? And then describe the relationship using words, an equation, and a graph. Okay? So in order to figure out what the equation is, figure out what's going on using words, and figure out if it's a linear function, is we're going to look at the difference in all of our y values. So as we can see, from 512 to 509, we are subtracting 3. From 509 to 506, again, we're subtracting 3. And then again, down here, we're subtracting 3. So this means that it's a linear function. It's a constant rate of change. So yes, linear function. And we'll be able to confirm that when we graph it. Okay? So next up, what we want to do is write our equation. So remember how in the last problem I told you that whatever this constant value is, you multiply it to x, and then you add whatever the y value would be at 0. And we actually have 0 here. So it's 0 is in line with 512. So this is your equation. You guys can write in words what happens. We know what happens. Every single photo you take, 3 megabytes are taken away, are left on, 3 less megabytes are left on your camera. So if we go to graph this right now, we have number of photos down here. And this is megabytes left on camera. Okay? So we start at 0, we go to 1, 2, 3, 4. Let's count by, let's start here. We can draw a little line here to say that we're starting late. 500. We'll do 505, 510, 520. 515, 510, 505 we'll do. Okay? So, 0 photos were taken and we were at 512. So that was somewhere right over here, right? 1 photo was taken and we were at 509, which is somewhere right here. 2 photos were taken and we're at 506. 3 photos were taken and we're at 503. So we can see that this is a line, right? This is a linear function. Great. So this is going to be one to do on your own. Wants to know what's the relationship. Is it a linear function? Describe the relationship using words, an equation, and a graph. So I'll quickly start you guys off. So what you want to do is look at the outputs. This is changing by a positive 2. This is changing by a positive 2. And this is changing by a positive 2. So yes, it is a linear function. Now I want you to write the equation, describe what's happening in words, and then sketch a graph. Great job, guys.